Good morning everyone. I am Harmeet Kaur from the Millennium School Batenda, and today we'll start with matrices of class 12th. In order to understand the operations on matrices, first of all we need to understand what is a matrix. First of all, a matrix is an ordered rectangular array of numbers or functions. The numbers or functions are called the elements or the entries. So first of all, what is a matrix? A ordered pair rectangular array of numbers. It can have any type of numbers, rational numbers, irrational numbers, so that we can say only real numbers. So in this array, there are some rows and columns. First of all, rows. Rows are the horizontal lines and columns are the vertical lines. So after the rows and columns, we should have the order of a matrix. Order of a matrix will always be a if suppose a matrix is having m rows and n columns, is that matrix will be called of the order m cross n, or we'll pronounce it as m by n. So next is number of elements in a matrix. So if we'll take the example of this matrix, this is of the order 2 cross 3, because there are 2 rows and 3 columns. So 2 by 3 is the order of this matrix, and the number of elements in A will be 6. Similarly, if we'll talk about this B matrix, here also the number of rows are 3 and the number of columns are 2. So it will be a matrix of order 3 by 2 where the number of elements will be 6. If we talk about the general matrix of m cross n order, in that case we'll have the elements aligned as a11, a12, a13 and so on till a1n, because there are n number of columns. First letter always denotes the number of rows and the second letter always denotes the number of columns. So here we have n columns. So in this element aij, where I is the number of rows and j is the number of columns, in that case a11 till a1n, and similarly am1 to amn. Next we have that we can represent any kind of data using the matrices. For example, vertices of a quadrilateral are given. There are 4 vertices. They can be aligned in any order. Suppose here we have A, B, C, D, and the order here is 2 by 4, and in this case the order is 4 by 2. So there's no difference. You can represent the data in any of these cases. So we can represent any information or any data in the form of the matrix. Next we have types of the matrices. So first of all, we have a column matrix. As its name suggests only, that the column matrix will only have one column and it can have n number of rows. Here we have taken an example of 4 rows, but the column is restricted to be 1. So here this matrix is a column matrix of order 4 by 1, where 4 are the number of rows and the columns 1. Similarly, the second type we have is row matrix. Row matrix, a matrix consisting of only one row. Similarly, as the column matrix, the row matrix will have only one row, where it can have n number of columns. So here in this example, there are 4 columns but only one row. So the order becomes 1 by 4. So in general, if we talk about, it will have 1 by n order. Next matrix is square matrix. Any matrix will be said to be a square matrix if the number of rows and the number of columns is same. If we say in generalized form, m is equals to n. If there is a matrix of m by n order and then m is equals to n, so we'll say that matrix is a square matrix. So here we have an example of a square matrix of order 3 by 3, or simply order 3. Next, there's a note regarding a square matrix only, the diagonal elements. When we talk about a square, we know a diagonal is also be there. So here the diagonal elements will be along the elements aligned along the diagonal. Here it is 1, minus 3, not the other diagonal. We always have to see the diagonal from the uppermost left corner to the downward right corner. So this line, this diagonal line, will depict the diagonal elements, which is only given here. In this example, we have 1, 27 and 4 be the diagonal elements. Based on these, we have a diagonal matrix, a square matrix only. So here when we talk about diagonal matrix, we will not talk about any other matrix. Only square matrix can be called diagonal matrix whenever the diagonal elements are some distinct numbers, some distinct elements, and the other elements apart from the diagonal ones are 0. So we can say if non-diagonal elements are 0. So here this is an example of a diagonal matrix of order 1, diagonal matrix of order 2, diagonal matrix of order 3. Up next is a scalar matrix. Scalar matrix is also a square matrix, but in addition to that, it is a diagonal matrix in which all the diagonal elements are same. Diagonal matrix and scalar matrix, there is a difference that here the diagonal matrix would be anything, any distinct element, but in scalar matrix they has to be equal. Here it is the example of order 1 matrix, scalar matrix, order 2 scalar matrix, order 3 scalar matrix. You can see that the diagonal elements are same. So we can generally depict this as Bij. If B is the matrix, Bij, the elements are 0 if I is not equal to j, and whenever they are equal, there will be a constant which are equal in each case. And the next thing is identity matrix. Again, we have to keep in mind the scalar matrix, first of all the diagonal matrix, then the scalar matrix. Then identity matrix is a square matrix in which the diagonal elements are same, but also they are 1 only. Identity, we all know identity. So in identity in itself reveals that it should be 1. So here the diagonal elements will be 1. It is an example of identity matrix of order 1, of order 2 and of order 3. Next we have a zero matrix. Zero matrix, as its name suggests only, that a zero matrix is in which all the elements of the matrix are 0. All, not the diagonal, not any other, and it is not that it has to be a square matrix or so. It can be any type of matrix, right? Next we have equality of matrices. Whenever we call two matrices equal, there are two conditions for that. First one, they should have the same order. Obviously, two matrices will be called equal if they have the same order. Secondly, if the corresponding elements are equal. That is, for example, if we say these two matrices, will they be equal? No. First of all, their order is not same. Secondly, the elements are not same. Corresponding elements are not same. So, when will we say two matrices are equal? If I have 1, 2, 3, 4. Second matrix is 1, 2, 3, 4. These two matrices are equal because their corresponding elements are equal. Their order is same. That is 2 by 2. Right? So, here we have done types of matrices, equality of matrices, and what is a matrix. This information will be sufficient for you to solve exercise 1.1. So try that and let me know.